first chapter, we're going to go over a lot of vocabulary, so kind of bear with me. So the first thing that we're going to talk about is what are statistics. Basically, statistics are when we're collecting, organizing, and interpreting data that someone else has done an experiment or an observation to collect, and you need to do something with it. The important part about collecting data of any kind is that it needs to be unbiased and random. If it's not unbiased or random, it is pretty worthless information. An example of a biased sample that somebody could get is what's called a voluntary response sample. Basically, it's a sample or a group of people that can choose whether or not they're going to actually be included in the study. For example, I give out a survey to my students, but I let them decide whether or not they actually want to take it. That's what it means to be voluntary. You don't actually have to do it, so it kind of takes away unbiasedness because people are making a choice as to whether or not they actually want to complete the study. Here's another example. In a survey of 109 subjects, each was asked to indicate how many text messages they send and receive each day. The sample consisted of only those who chose to respond to the request on the MyStatLab website. So there's a couple issues with this. First of all, you're only getting people who are accessing the MyStatLab website. That is certainly an issue. So we're not actually representative of any group of people, just a certain group that are accessing MyStatLab. Another issue is it's not required. They have to choose to actually respond to it. And how did they probably even know about it is that they were receiving a text message. So there's all sorts of issues as to whether or not somebody would even know about the survey if they didn't even receive the text message. So this is definitely an example of a flawed sampling method for a number of reasons. It's because you're requiring people to have text messages and have the MyStatLab website, and you are not making it required. It's a voluntary sample. It's a voluntary sample. It's not a good representation of everybody, and it's assuming you got a text message. That's a lot. Continuing along, there is this thing that you hear a lot that people draw conclusions, and there's something called correlation and there's something called causation. Correlation means that two things might be related. There might be a relationship between them. But two things being possibly related to one another or having a relationship doesn't mean that one causes the other. That is what we're saying here. Causation, something causing something to happen, is not the same thing as one thing being related to another. This can, if you actually think that things being related means that one causes the other, can actually lead you to make conclusions that are completely unsound. A really good sciencey example of two things that are related or have a correlation are bad smells are usually caused by germs. And germs also cause disease. For that reason, there's usually a relationship between when you have bad smells and diseases. They usually are correlated. However, that doesn't mean a bad smell happens as a result of a disease or vice versa. that a bad smell causes a disease. So those two things may be related. If you have germs, they'll cause bad smells and diseases. So those two things would be related to one another. However, they don't cause one another. Continuing along, another huge issue that you see a lot is that a lot of people do an experiment or give you a bunch of data and making a conclusion, but it will be on a very small sample. That just is also another way to give you some worthless information. If you want to say something about the entire group of all people in the United States and do a study that you want to say something about everybody, but then you take a sample of, let's say, 30 people. How can you possibly think that you can say something about everyone when you're only taking a group of 30 people and looking at them and asking them or experimenting on them? It just doesn't make sense. That's why a lot of these clinical trials and whatnot, they need tons of data in order to prove something. They need years and years and years of data so that they can have a large sample, not a small one, to actually have some strength behind what their conclusion is, behind their study. So let's take a look at an example and see what kind of conclusions you can draw and whether or not the conclusion they draw is a good one. Data was published to show that there is a correlation between the number of times songs are played on the radio station and the number of times the songs are actually purchased. The conclusion is, increasing the times that songs are played on radio stations causes these sales to increase. It's plausible that, yes, by playing it more, you're making it more popular, which could cause the sales to increase of that song. However, it could also be that the reverse is true, that the sales have increased, it's getting popular, so in return, it's getting played more on the radio station. It actually could be the reverse. Something's getting played so much on the radio station that, hey, guess what? It stops actually getting played because people get sick of it, and it will cause sales to actually decrease. So just because there's a correlation doesn't mean that something is causing something else. It could also be that that particular song is getting purchased because of the time of year. If it's a Christmas song, people are just purchasing Christmas songs. It just all depends. But just because two things seem like they're related doesn't mean that one is actually causing the other. Could be that the song is actually on sale, so people are buying it to see if it sounds good. It just all depends. And it doesn't mean that that's what's causing it. Let's look at example B. A minority group failed the fire captain's examination at a much higher rate than the majority group. Their conclusion was that the exam must be biased and causes members of the minority group to fail at a much higher rate. Not necessarily. It might be that the exam isn't biased. Maybe it's that it's in a different language than what they're used to, or the wording is a little bit strange, but that doesn't mean that it's necessarily biased. It's just maybe not written for them. Maybe it needs to be retranslated into a different language. Maybe it's that the minority group doesn't have the same reference capabilities, that they don't have the access to the same computers, books, and study techniques that the majority group does. So just because a group of people is failing at a higher rate doesn't mean the test is to blame. It could be a variety of other outside factors, such as their home lives. They may have busier home lives. They might have 2 jobs instead of 3. They might also have kids at home, family at home that they're taking care of. just because things seem to be related again, it doesn't mean that one is causing the other. There could be a whole host of other issues, but they are related. The question is why. Let's take a look at this next example, A. AOL surveyed 7,073 people, and 4,650 said that they preferred a real Christmas tree to a fake one. Given that 4,650 is 66% of the 7,073 respondents, can we conclude that about 66% of people prefer a real Christmas tree over a fake one? Well, this is kind of a loaded question because, first of all, you're only asking AOL users. The question is, first of all, who uses AOL anymore anyways? So you've got a limited sample group. So that is your first problem, is you've got a limited sample of AOL users. Okay, so can you say something about everybody? If you're just sampling the AOL users, no, it's really not fair. So you can't say something about a whole group of people, but just a small group of specific people that are using AOL when we're not even sure, how many people still use that anymore. That's not really something that most people use anymore. Let's take a look at another one. Let's look at B. A patient is asked to complete a survey regarding their physician. They are also informed that their name as well as their responses will be given to their physician. What's wrong with this one? Well, if you are going to give my name to my physician, because that's what they're telling me, they're going to give my physician my name as well as whatever response I give. How do you think I'm going to answer this survey? Well, first of all, either I'm not going to respond to it, which is going to give it the issue of it being a voluntary sample. Or if I do answer, I might lie. Why? Because if it's going to be given back to my doctor, I don't want to receive negative treatment or anything like that. So the question of honesty is an issue because it is not, my identity isn't hidden. Here's another one that seems actually rather straightforward, is what if you're looking at a survey like this? What's wrong with the question on a survey that says enter your height in inches? Well, I know what my height is, but I know it in feet and inches. So if you ask me to tell you my height in inches, I'm either going to have to do one of two things. I'm either going to have to guess or I'm going to have to do a calculation. What's the problem? If I'm guessing, I'm not actually giving something accurate and I could be quite off. If I'm calculating, I could be making a mistake when I turn my inches into feet. So asking a survey question of what somebody's height is in inches is really meaningless because you are probably not going to get accurate answers either due to guessing or calculation errors. So you might as well reword your survey in a way that people can understand.